FastMCP 3 implements a hierarchical visibility control system through provider-level and server-level transforms, enabling dynamic component enablement and disablement at runtime. This artifact demonstrates how provider-level enable operations can be overridden by subsequent server-level disable operations, establishing a precedence hierarchy in the visibility transform pipeline. The upcoming code will reveal a local provider instance that enables components tagged with feature, followed by a server-level disable operation targeting the beta tag, showcasing how later transforms override earlier ones in the visibility resolution chain.
From FastMCP, import FastMCP. From FastMCP server providers, import local provider. Provider equals local provider. At provider, tool tags equals feature, beta. Def new feature SDR. Returns new. Hash provider enables feature tagged. Provider, enable tags equals feature, only equals true. Hash server disables, beta tagged runs after provider. MCP equals FastMCP server. Providers equals provider. MCP, disable tags equals beta. Hash new feature is disabled. Servers later disable overrides, providers enable.
This code demonstrates FastMCP's layered visibility control system, where providers and servers can independently enable or disable components, with server-level rules taking precedence. The pattern shows how component visibility can be managed at different architectural layers, allowing for flexible access control and feature flagging. At the provider level, the local provider enables all components tagged with feature using only equals true, which creates an allow list where only feature-tagged components are visible. This is a restrictive approach that explicitly opts in specific components rather than opting out unwanted ones. The provider then registers a tool, new feature with both feature and beta tags, making it visible under the provider's allow list rule. The server level introduces an override mechanism where the main FastMCP server disables all beta-tagged components after the provider's rules are applied. This demonstrates the hierarchical nature of visibility transforms. Provider transforms run first, then server transforms, with later rules overriding earlier ones. The result is that new feature becomes disabled because the server's disable rule takes precedence over the provider's enable rule, even though the tool matches the provider's allow list criteria. This layered approach provides several advantages. It allows providers to set default visibility policies that servers can selectively override, enabling scenarios like module-specific feature flags that can be globally disabled. The only equals true parameter creates a security by default posture where components must be explicitly enabled, while the override mechanism ensures central control. However, this complexity requires careful ordering of transforms and clear understanding of the precedence rules to avoid unexpected visibility states. Let's break it down.
From FastMCP, import FastMCP.
Imports the FastMCP class from the FastMCP module, which provides the core server functionality for implementing Model Context Protocol (MCP) services. This import alone doesn't create any server instance or configure any behavior. It simply makes the FastMCP class available for use in the current scope.
From FastMCP server providers, import local provider.
Imports the local provider class from the FastMCP server providers module, which is the default provider for components defined directly in the server code.
Provider equals local provider.
Creates a local provider instance and assigns it to the variable provider. This establishes the default provider for storing components defined directly in the server code, such as tools, resources, and prompts registered via decorators. The local provider will be the first source queried when clients request available components.
At Provider, tool tags equals feature, beta, def new feature SDR.
Defines a tool function named newFeature that returns a string, decorated with metadata tags, feature, and beta for categorization and filtering purposes. The decorator registers this function as a callable tool in the provider system, making it discoverable by clients and subject to tag-based enable-disable operations.
Returns new.
Returns the string literal new as the output of the current function or method.
Hash provider enables feature tagged. Provider, enable tags equals feature, only equals true.
Enables all components tagged with feature on the provider, making them available for client use. The only equals true parameter ensures that only components with this specific tag are enabled, while components without this tag remain unaffected. This is a bulk operation that targets components by their tag rather than individual keys.
MCP equals FastMCP server. Providers equals provider.
Creates a FastMCP server instance named server with a single provider specified by the provider variable. The server identifier server will appear in MCP protocol handshakes for client identification, while the provider parameter determines the source of available tools, resources, and prompts that this server will expose to clients.
MCP, disable tags equals beta.
Disables all components tagged with beta in the FastMCP server. Any tool, resource, or prompt marked with the beta tag will be hidden from client queries and cannot be invoked until re-enabled. The disable operation applies to all providers in the server, including both local and remote components. FastMCP3's hierarchical visibility system lets you control component access at two levels, provider and server. The provider sets initial rules, here enabling only feature tagged components with only equals true for strict opt-in security. Then the server layer overrides with broader policies, disabling all beta components regardless of provider settings. This creates a precedence chain where server rules always win, giving centralized control while letting providers define defaults. The newFeature tool gets caught in this hierarchy, enabled by the provider's feature, tag, but ultimately disabled by the server's beta rule. This pattern balances modular flexibility with system-wide governance, though it demands careful ordering of transforms to avoid visibility conflicts. The only equals true parameter enforces security by default, while tag-based operations allow granular control without hard-coding component keys.
The provider tags the tool with feature. The server tags it with beta. Both agree. Yet the tool vanishes into silence.